Okay, we're going to go ahead and get started on our third video, which is plotting irrational numbers on a number line. So the whole goal by the end of this, you should be able to do very similar to what we did yesterday with plotting rational numbers. The only difference will be that we will be plotting irrational numbers. Okay, so let's get started. So if we look at this, first we are given a number line. We need to find the appropriate intervals. And then with the appropriate intervals, we're going to plot the square root 5, which I'll make a little bit bigger here for us. Okay, so let's start with the intervals. I look between 0 and 3, and I have 1, 2, 3, 4, 5, 6 spaces. So I start to take 3 divided by 6, and when I do that, I get a half. And so I can see that I'm going up plus 1/2 each time. So this would be 1/2. I'm going to go ahead and put it as a decimal. This would be 1 and 1.5, 2, and then 2.5. So notice, again, we're adding 1/2 or 0.5 each time. Once we've found our intervals, then it's rather simple. What we're going to do is we're going to take this irrational, and we have to come up with an approximated value. Because remember, what makes it irrational is that this decimal is going to go on forever without ending or without repeating. And so since it goes on forever, we have to come up with some kind of approximated value. So I'm going to round it to the hundredths place. If I take my calculator and I type in the square root of 5 and hit enter, I get a number that says 2.23606, and it keeps going on forever. I'm going to round it to the hundredths place, so I look to the right. It's 5 or more, so I'm going to add 1 to it, and I'm going to say that the square root of 5 is approximately 2.24. Now I take that and I graph it down here. So since I know the whole number is 2, I'm going to be somewhere in this region here. And I have to ask myself, is 2.24 bigger than 2.5 or smaller than? Where is it close to? And so as I start to dive in, I start to realize that 2.2, like if I made this 2.1, 2.2, 2.3, 2.4, then 2.5, 2.24 is going to be very close to the center there. So if I'm graphing it, it's actually going to be right as close to the center as possible, and it's always important to label it with the original. So we're going to label it with the square root of 5. And that's how we graph an irrational. Okay, let's try another one. This one's the square root of 24. Again, I'll make it bigger. First thing, though, I need to find my intervals. So I'm given -1 and 1, and I need to find out, since there's 2 spots, really what's in the center of those. It's going to be 0. So now I know that each interval is increasing by 1. So this will be 2, 3, 4, and 5. Now I take my 2.24, I'll bring that over here. And remember, we're coming up with an approximated value. I need to use my calculator. And with my calculator, I want to type in square root 24. And I want to get 4.89897, and it keeps going on forever. I'm going to round it to the hundredths place. This is 5 or more. So I add 1. And it's going to actually work out because it carries over to get 4.90. And again, that's approximately. The square root of 24 is approximately 4.90. We have to round it because it goes on forever. So now I go to my number line. It's going to be in between 4 and 5. Since it's 4.9, I know it's going to be closer to the 5. I plot my point, and again, I put the original value, the square root of 24, above it. Here's another example. This time, instead of getting a square root, we get a decimal that goes on forever. First thing I'm going to do, though, is I'm going to fill in my values. I notice that there's 1, 2, 3, 4 intervals in between 1 and 3. So if I take 3 minus 1 to find the difference there, I know I'm going, this big jump is plus 2, but I've got to divide that by 4, and that's going to give us intervals of 1/2. So smack dab in the middle here is going to be 2, and then we're going to have 1 and 1/2, or 1.5. and 2 and 1/2, or 2.5. Then we're going to go up 1/2 each time. 1/2, 1/2, 1/2, 1/2. So we're going to get 3.5 and 4. 3.6 is going to be just past the 3.5 in between that and 4. So I'm going to put it right about here. And then again, I put the original 3.645 with 3 dots afterwards. And that's it. Let's try another one. This one's the negative version of a never-ending, but not never repeating decimal. Again, I need to find my intervals. I look at -1 and 0 and notice that in between that is -0.5. And then beyond this will be -1.5, because notice I'm going back a half. And if I work this way, I'm going forward a half, so I'm going to have 0.5. And then 1/2 again will be 1. And another half is 1.5. Now this one gets to be a little bit tricky. The common mistake is to find the -1 or 1/2 and then put it just on this side, because you're starting to think kind of in the positive world, because if it was positive, that's where 5.21 would go. But this is the negative world. So remember that we have to start at 0 and we're going back 0.5 and then plus a little bit here. So it's actually going to be here on the left side of -0.5. And we then label it. And we're finished. And that's how we plot irrational numbers on a number line. We'll do some more practice tomorrow in class, so good luck. I did have one other problem, which was this one right here. Go ahead and try it on your own, and we'll see if you can get that, and we'll go over it in class. Remember, you have to use an approximated value for pi. So we've learned over the years approximated value for pi. Use that and plug it in. Good luck.